Hello, and welcome back to maths. We're going to continue working on our fractions today and continue looking at mixed numbers and improper fractions. But we're going to do it the other way around. So we've gone from improper fractions to mixed numbers. Now we're going to go from mixed numbers back to improper fractions. And realistically, if you can do one way, you should be able to do it the other way, either by drawing out the diagrams or by following the trick that I talk about in this lesson. So first, I just want you to have a go at these, please, for me. Pause now and have a go. Okay, so first off, write the fraction as an improper fraction. We're looking at how many are shaded and how many in total are there. So each whole is split into 3 parts. We've got 4 of them. So it's going to be 4/3. The same is here, write the number as an improper fraction as an improper fraction. So each whole has 4 parts, can be quarters, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9 in total. So it would be 9 quarters. Then complete these part whole models, and all we're doing is putting them back together again. So 5/5 and 3/5 put back together again is 8/5. And then the opposite way around, we've got 11/6 here and 6/6 here. So what would we need in order to fill in the last ones we need? And that's 5/6. So just a quick recap on what an improper fraction is and a mixed number. This would be 3/2, and this is an improper fraction as the denominator is larger than the numerator. The numerator is larger than the denominator. If we were to change that to 1.5, being the mixed number of it, this is the mixed number which has a whole number and a fraction, and that's why they're called mixed numbers. So in this regard, we have 2 parts here. We've got 2 in one and a quarter in the other. We put them together and we get 2 quarters. 2 quarters is our mixed number. So 2 quarters would look like this if we were to write it down or show it as a diagram. We create a whole and we split it into quarters. We know that because of what the fraction is here, and we use this as our guide as to what we're going to split our whole into. So we will need 4 pieces per whole. So do that. We color 2 in completely. That's the 2 here. And then what we can do is just count how many ones are shaded. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 in total. There's our 2 holes. Each hole is 4. So that's 4 quarters plus another 4 quarters plus 1 quarter. So in total, that's 4 quarters and 4 quarters is 8 quarters plus another quarter is 9 quarters. 9 quarters in total. And you can actually see here, when we add fractions together, this is a hint from before, when we add fractions together, nothing happens to the denominator, and we just add the numerator together. And that's it. That's as easy as adding fractions is, really. But the way to do it, remember, when we're creating our bars, it's the fraction that we know is the fraction that we set up our bars as. So convert mixed numbers to improper fraction. Have a go, try this one and see how you can do. Pause now. Okay, so hopefully you can see that each of our wholes here are split into 8 because of the denominator we have here. And then we've got 3 full ones, 1, 2, 3, and then 5 in the end one. And you could just count them, or you can know that you've got one whole one, which is 8/8, another whole one, which is 8/8, another whole one, which is 8/8, plus those 5/8. And then we leave the denominator alone and we add the numerators together. We get 29/8. And you can actually just count that. We can count round and count all of them out as well in that regard. There's another sneaky way we can do it, and we're going to talk about that in a minute. But let's have a look. What can we see? Well, we've got 3 8s here, don't we? Plus that 5. So what we actually do, the whole ones we know are going to be 8/8. Every single whole one is going to be 8/8. And it's 8/8 because of the bottom number down here. So what we do when we're converting is we times the number of whole ones we have by whatever the denominator is. Then we add to that amount whatever the numerator is. So we take 24, add the numerator, which is 5. and that equals 29, and then we just put that on top of the denominator again, and you get our answer. And the reason why that works is you're doing 3, and you've got all 8 of these ones, which is why you can times it 3 times. And here it is, look, 1, 2, 3, 8. And that's why we do this step. And actually, it just means we can skip out this bit. It's a nice quick shortcut to the end. So have a go at these. There are some some diagrams on one side. You can use bar models on the other side to help you. Pause now and have a go. Okay, so we're having a look at the first one. We've got quarters here, so all of them are split into quarters. We've got 2 full ones and 3 here. And then we can just count them together to get our answer, which is 11. And exactly the same for these ones. It's just remembering that we've got them split up. They're split up because of the numerator. We can just count them. If we're doing exactly the same over here, we know that we're thinking in quarters because of the 4 there. So we do 2 full ones, 1, 2 full ones, and whatever we need, 1, add them together and get 9. And the same goes for all these. Or we can do our trick. So let's just see if it would work for this question here. We said we have 3 lots of 5 fifths. That's 3 times 5 is 15. Then we have an additional 2, so it's 15 plus that 2 equals 17. And then we just put the 17 back on top of our fraction. And there it is. So it works nicely. And the reason for that is that 3 times 5 is relating to these ones here. 3 lots of 5 because they're 4. So to convert mixed numbers to improper fractions, this is what we go through what we've just said. This is the 5 and 1/6. Now, it takes a long time when you start getting to higher numbers, which is the problem. But 5 whole ones is the same as saying 5 lots of 6 sixes. So 6 sixes equals the same as 30 sixes. And you can see that because what you're doing is doing, if you look at this, look, 5 times 6 is 30. We keep the denominator the same. Nice and easy. And then we just add on that one last one. That's 31. So let's have a look. Going to give you So converting mixed numbers to improper fractions. Have a go and then we'll talk it through. Pause now. Okay, so first off, we have two holes. So 2 times 5 is 10, and it's over 5. Then we need to add the 4 on to get 14 fifths. Same over this side, we do 10 times 6 to get 66, and then we add the 5 on to get 65. And realistically, as long as you remember that, when you're timesing a number by a fraction, that's how it works out. And that's the easiest way to remember it. So here we are. What you've got is a few questions here, and our last question, number 6, is a little bit of a reasoning one, working out what it could possibly be. Some worded questions you might have to think about and just work out what they mean. And try and work out how this relates to improper fractions and mixed fractions. Pause now and have a go. Okay, so here's our answers, but let's talk through them just so we know. So the first one it says here, convert the mixed numbers to improper fractions and write the next conversion in each part. So it said 2 and 1/7 is 15 because 2 times 7 is 14 plus the 1 is 15 sevenths. Then 2 times 7 is 14 plus 2 is 16, then 17. So if we're looking at the next step, it's 2 and 7, 4 sevenths would be 18 sevenths. And it's just following the pattern along. B, 3 times 3 whole 5 fifths would be 15 plus the 1 is 16. So then 4, what we're doing is actually increasing the amount of wholes numbers here rather than the fraction. So the difference here, each whole number we add on each jump we make is 5 extra fifths. So we just add 5 each time. There's add 5, that's add 5, and that's adding 5 fifths as well. And each of these are 5 fifths, but we don't, when we're adding fractions, we don't need to worry about changing the denominator. And exactly the same here. This is plusing 1, and this is adding 5 fifths. And that's the pattern for that one. C, what's the difference between this one, and this one? Well, the interesting thing here is what's the different bit is what the denominator is. So these are actually significantly different, but there is a pattern if you have a look, if you go down. So 5 and 1/2, so 5 times 2 is 10 plus 1 is 11. Then we've got 5 quarters, 5 times 4 is 20 plus 1 is 21. 5 times 8 is 40 plus 1 is 41. So that's nice and easy, but what we're actually doing here each time is interesting. This is adding 10. This is adding 20 to the denominator, at least. And this one here, if we follow the trend, 10, 20, 40 it would be. That goes from 40 to 80. Or you can just work it out because you know that you're halving. This 2 goes to 8, and this 4 goes to 8. You're timing by 2 each time. 2 different patterns depending on which way you go. Okay. Going down to number 4 down here, we've got, there are 4 whole pizzas, 1, 2, 3, 4, nice and easy, and 3 fifths, which is this bit here, of a pizza. So we've already got a diagram that shows it. It says how many children can have 1/5 of a pizza each. Well, this should be nice and straightforward because we're just counting the number of fifths. And we could literally count them as we go around, or we've got 4 whole ones here. So 4 whole ones, if we think about this, is the same thing as 4 times 5, which is 20, plus the 3 there equals 23. So number 5, Whitney is converting mixed numbers to improper fractions. She's got 4 and 1/7, and she's saying it's the same as 28/7. Do you agree with her? No, and we have to think about this one. But what she's done is converted the 4 wholes to 28/7. 4 times 7 is 28. But she's forgot to add that 1/7 on to make it 29. And that's the problem with what she's done. Now, this is interesting because what it's saying is the circle here, if the circle is a 1, so imagine that's 1, what's our triangle going to be? And that's going to be 1 times 5 is 5 plus 3 is 8. So the 8 goes there. And then you just fill in the pattern as you go down. And when you get to this stage here, yes, there's a pattern between these two. It doesn't link into one before it. You just have to think about what our numbers are. And this one here is quite an interesting one. And you have to think of a way to do it. But realistically, the easiest way to do it is take this number, 800, and divide it by 5. And that's then leave the 3 left over because you know that the 3 left over is going to be those ones there. And that's the way to do it. Okay. Hopefully that's not too bad and you understand what you're doing. It does link into the last 2 lessons as well. So try your best, see what you can do, think of the trick, and if not, just draw it. The pictorial representations of fractions really does help an understanding of what you're doing and what you're looking for. I'll see you in the next video. Goodbye.